Well, hello, and welcome back, everybody, on this wonderful windy day. You're going to hear some wind. You're going to hear some typing. The code's going to fly. It's going to be great. I hate saying it's going to be great. Forgive me for saying that. Anyway, yeah, last night was kind of mind-bendy, but I think I've got it now. So we're going to try to match denomination. So we take the payment and we say, okay, here's how we can split down the payment. And we're going to try to use smaller coins that are in the same range of denomination. I think we're going to try to use those up first. I mean, I don't know. I'm not going to worry about it too much. But there's going to be a basic thing that's basically try to match the coins. And if we can't match the coins, then... So first match the coins straight across, and then try to use a few smaller coins, or a single larger coin. Maybe. I don't know. We'll figure it out. And I don't know how to keep the door open. So it's just going to go open and shut with the wind here. Oh, and let me get rid of that. There we go. I'm not listening to a podcast today. Let me try to get rid of that. But I'll see what I can do about the brightness. The brightness is going to go up and down as the door opens and closes. But with that out of the way, let's go ahead and open ourselves a nice fresh can of Focus. Pop top, my friends. Let's have at it. Okay. Oh, it's weird, isn't it? Having the wind. The wind that strong. Okay, so we've got the wallet. Let me just see what I have in my paste buffer here, because I have something in my paste buffer. I've got that nagging feeling. Oh, it's the going live. Okay, great. So we got that. I think I'll pop that into the Dash channel as well, because I think today's stream will be a good stream. We're gonna have a couple of streams today. Yeah. And then we're going to get rid of that. Boom. Okay. And I don't know what I just saw. Oh, it's just, I'm live officially. According to the software, it now knows that I'm live. All right. So I was trying to get some testy-like stuff for this, and the idea is, so we're going to have a bunch of inputs. Potentially. We're going to have a bunch of outputs, potentially. And what we need to do is make sure that for any given output, the amount of money that's sent is slightly greater than what's requested. By, a fraction of a penny, essentially. Well, or maybe even a whole penny. But this is how we do a cash-like send. Alright, so... Let's see. And then, I think this should not be denominate payment. Let's get that out of there. Denominate payment, which should be denominate amount, because it goes either way. It could be a payment or not. And let's see. And I think there is a little bit of a question here, because for whatever the next is, so the denoms is how much this will split into. So essentially, if they requested this much, I just need to make sure that whatever... here's what we got to do. So we take... We get the value of all of these together. And it should be at least that of this. Otherwise, we have to pull in next. And I guess we know what next is. Next is always going to be the smallest denomination. So if we just have some way that we calculate whatever the smallest denomination is, then that could really just be a flag. Okay, so that kind of makes sense. And to some degree, we want to work with the smallest units that we can, because those are the ones that are going to tend to pile up, so the ones that we want to get rid of quicker if we can. We definitely don't want to be in a position where we're trying to match up lots and lots and lots of little coins. Yeah. Okay. So let's see here. With all of this, let's get back to my original example, which I think this is kind of my original example. Not quite, but kind of. Okay, so what I want to be able to say is, what's the amount that I actually want to send? Hold on. Okay. I've got a super even... So this is the thing. Request amounts should be capped at 3 digits. That's what should be done. This is going to get truncated down. So I just I just had that in there so that it wouldn't get truncated down. Just so that we could see kind of the scale of this. So that extra 1 doesn't mean anything. But I want the extra zeros. I actually don't want them to be lobbed off. I really need a bug fixed in JS Hint. Well, the bug is that the language of JavaScript is always changing, but I really, 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 really want to be able to use this. But I get this problem with JS Hint doesn't know what to do. I'm going to check and see real quick if JS Hint has an update on that. Because it's really, really obnoxious to not be able to use the underscore numbers. Let's see. Is there anything here? JS Hint GitHub. I don't know why I'm doing this on the other screen. Sorry. Okay, going into the JS GitHub repo. Let's see if they're even going to do it. Yeah. Okay. So there's just an open feature request on it, but this is one of the things that bugs me the most about my current tooling that I really wish that I could. What? Okay, yeah. Needs a parser. Okay. Anyway, so still no love for that. All right. We just when working with these types of numbers, we really need that. We really need it. There's too many zeros to be understood otherwise. Okay, so I'm just going to try to get this actual payment to happen. Except that it's not really going to work because I don't have. Let's see. I've got that as an input, and what do I want to do as an output? I want to do an output of. Let's see. I guess there's a couple of ways we could do it. We could say if you select these inputs, then we're going to use those inputs, period. And whatever change we send back is the change we send back. All right, let's consider the outputs here. So the outputs are really it's going to be a handle, and this is going to be Kraken, and it's going to be an amount, which is going to be roughly, I'm going to be doing something like 26. We'll just leave it at this. It's fine. Whoops, what did I do? Unexpected comma. Where? Alright, so we'll see. This probably just can't work. No, it can work if there's enough ways to go about it. Okay. So what I need next is I need to basically select the coins. So let output of outputs, and I can get any number back to myself. But in order to get it out to Kraken, I need some minimal number of addresses that can be used. So in order to send that amount, I need to have whatever number of addresses that requires. So let's basically do the same thing here. And for this output, I need a certain number of addresses. And I had some other name last night. I don't remember what I called it, but not output because this is different from what we already call an output. This is maybe an X output. Okay, but we need to be able to see what are the number of denoms that need to go out for that. And we need one of two conditions. Either have enough addresses to send to... This is the ideal. Either have enough addresses to send denoms to recip, or have enough round inputs to send to a single recip address. That's how we're going to do it. All right, why is it griping? Unexpected token, comma, on line 150. Where's line 150? Oh. Got it. I see why it's griping at me. All right, so number of denoms. So we can say if, and do we know how many addresses we can have at this point? I don't think we do yet. So let me see addresses. All right. Okay, we probably could just have some sort of signal to say it's either a finite number of addresses or it's an XPub. So if not output.xpub, which it won't be, so if output.addresses.length, let's see, has sufficient. Because I know for myself I can produce as many addresses. Okay. Throw new error. Not enough addresses. Use single address. Something like this. Finding matching inputs not implemented. Okay. So what do we do next? Okay. All right, so then in this case, all we need to do is split up between xpubs and excess addresses. We just need to split them up, and we're going to be good. Okay. All right, let's try this. Need requires at least denoms.length addresses, but only have, whoops. Wow, really? Requires at least 13 addresses, but only have 9. How so? That doesn't seem quite right. That seems like it should be 2 10s, a 5, and a 1. Seems like that should be 4 addresses. So what went wrong here? I guess we could call this denominate output. Because it's different if it's an input because it needs to have more of the change addresses calculated. Okay, denominate amount. Console.log denoms. That doesn't look right. While remainder is greater than denom. And I could do this a different way, actually. Well, no, because I got to push onto it, so that kind of makes sense. Two, 2, 7, 2, 7. What? Yeah, that just doesn't make sense. I'm not. I'm not clear how we got there from here. Oh, maybe it's really big. It's because it's Satoshi's, and maybe it was thinking it was an amount. Okay. Okay, that is going to be in Satoshi's. That's fine. $2,999. Why is that coming out that way? Bless me. Because it seems like that should have come out pretty even. I mean, I guess this is kind of right. Because we want these to each come out with stamp values, but this doesn't quite seem right. Okay, what went wrong here? Okay, but that's inputs. But still. Yeah, I guess. Okay, let's change that to output. So something went wrong here. Maybe there's a rounding error there? I'm a little confused. Oh. Greater than or equal to. Alright, let's try this out. That should work a lot better. Yes. Yes, there we are. Okay. Okay, so that makes a lot more sense. Well, actually, hold on. I see why it doesn't. Because the remainder should be greater than the denom. So this is actually correct. Because output should always include stamp values, so they should always be greater than. Now, comes a question of other inputs. We can take this on the small scale first. So basically, if there's only one input and only one output, let's see. See. Okay. This is one of those frustrating things. So in the end, yes. In the end, the denominations should have stamp values. But as inputs, maybe they don't. So this is one of those cases where, again, it's kind of a cyclic dependency. Because we could say, okay, well, put in these denominations, but they should have some sort of stamp value. But I think that should come at the end. And all the stamp values should be taken into account. Let's see. Okay, let me go back and look at this. All right, so here let's see if I was given. All right, let me just do it for the actual use case and then build from there. Oh, either have addresses. Okay, and in this one, what are we looking at? And this one, it needs to have at least this amount of stamp and at least this amount of dust. So we could just put an extra stamp there if needed. But those stamp values are kind of discounted. Let's see. Okay, so we want to see... Okay. Okay, when we look at the output as a total, I think what we want there... Hey, what's up, Joe? Yeah, it is. Well, it's actually... It's kind of a windy and cloudy day. I mean, it is a beautiful day, but it's not... it's not beautiful in the sense of this would make a good photograph for a vacation postcard. Okay. So let me think about this here. So output of outputs. Timestamp, total stamps, dust. But this shouldn't matter because basically we just need to know for every full output. I'm going to rename this X output because it's a little bit different what we're trying to accomplish here than an output. So I'm going to call this X output of X outputs because these are extended outs. So we're trying to find for this extended out to get at least this many Satoshis. Which means let's see. I don't think we're really concerned about the stamp values. I'm going to comment these out for now. So I think it's just if next denoms dot push next. Because we're going to take whatever's left over, whatever's required, and we're just going to mix that. We're going to push that in so we always get stamp values. Because if we don't do that, then we may not have... I guess it depends on what the stamp values actually end up being. Well, the code looks beautiful. Yeah. I don't feel that way about this one in particular, but it's getting there. It'll get there. I'm not sure which way to go about this. Yeah, I think that for privacy's sake, or rather for not fingerprinting's sake, any amount that's required over the exact amount just needs to be considered an extra coin. So even if it's 1 Satoshi over, it needs to be a whole extra coin. And the reason for that is that if we start trying to distribute, well, I guess we could maybe make this decision later, but if we start trying to distribute change as an amount, then it starts to be a fingerprint. So we can't let the stamps ever be part of the influence of whether something is greater or less. But we could just recalculate if there's not enough of a stamp value. But I'm going to do it with just the whole coin for the time being, because it's less than a penny anyway. All right, so if it's got enough has enough adders, as we'll call this. Okay, let's get this the whole way through, and then I'll tinker with the stamp amount stuff. Alright, so let me just run this. Requires at least 11. Alright, so I'm going to go back to this being greater than or equal to. And this is actually a really good example because it will be wrong. One problem, though, is it will tend towards smaller values being return change. That will still be a trend that the smallest value, or will it? One of the smallest values is likely to be changed. I think that will be true. Anyway, we'll just carry on here. Get to the end of it. Get through a whole full loop. Get the actual end calculation. Okay. So we have all this. And then we need to go back to the inputs here. So we've got that as an input. Okay. So calculate what the outputs need first, and then what was our actual calculation? Coins needed. So we got the door open, and there's a fair amount of wind. One of the things that I don't like, though, is a lot of this dust is actually fiberglass dust. That just hasn't had a chance to find its way out yet. And I guess ultimately, I want the fiberglass dust to find its way out. Hold on, I'm going to open up the window over here. This is going to cause all sorts of problems, but it'll hopefully get the fiberglass flowing in one direction. Maybe I will have to have the door closed. I think that wind's a little too strong. But let me just open the windows slightly. So the air isn't so stale in here. And so that some of that dust hopefully can find its way out. It's been in here all winter. Okay, back to this. All right. So that's the outputs. Okay, the outputs. Sorry, this actually needs to be for that coin of coins needed. Outputs dot push. And then we need to have handle is going to be x output dot handle. And then Satoshi's, well, I guess we need to do it this way. Put some lotion on my hands just in case. Because we put the insulation in the winter. You know, that makes sense. And most of it's been cleaned up and vacuumed up and kind of let to air out, but as the wind blows, there's going to be a little bit more. I guess we need to put up some drywall eventually. Alright, so let coin, if coin's nested, coin. So these are the outputs that we're trying to collect. Okay, let me try this again, actually. There we go. So here's the simple logic. Something like that, maybe? I'm not sure which way I like it, but we'll leave it like that for now. Okay, so if there's enough addresses, then it's a very simple... We just need to get this number of coins out. No big deal. And otherwise, then we start to have error conditions. There we go. Alright, so now we're back to matching the inputs. And so... I think we want to take these outputs and we want to sort them. Oops. And this is something I gotta look up in my cheat sheet every single time, because I never, ever, 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 ever remember it. Really? Indeed, something did go wrong. Huh. Alright. I don't know what exactly went wrong. Okay. Ascending order from smallest to largest will be return A minus B. Okay. I think we kind of want to... Well, it doesn't matter which way we go about this. We just need to get it done first. So for each output, we're just trying to find an input that will work. And if that creates change, then we want to try to minimize the amount of change it would create. Yeah, I think we're going to have to test some of this out with just plain coin control. And maybe have some sort of debug output to show, hey, here's the proposed. This is what's proposed. Would you like to change it? I think that's what we probably could do to show, to allow coin control, but then show what it's going to propose to do. And then allow you to say, actually, no, I want to put this one in instead. All right. All right, so maybe we can do let start input equals -1. We can do for input of inputs. Start input index plus equals 1. We should, okay, I guess we should have a way. Yeah, we should have a way pretty early on. To just do a spot check on this. No, that's not going to work. Hold on. What is it? Let's see. Alright, so if there's not a sufficient balance, if the balance is too low, we'll just throw right there. So the point of that, there needs to be a couple of spot checks here, because I don't even want it to be possible for a start input index. I mean, this actually doesn't guarantee the condition that I want, I think. I have to think about this. It is possible that none of the inputs are greater than the outputs. And that's okay. We can... Okay, just worry about the one use case. Just the one use case. Because I'm trying to think. There's kind of two ways to approach it. You could say, well, we take it from the bottom, and we say, well, we want to get the... Basically, we want to get the best match of inputs. And so, the best match of inputs... Let's see how we define this. So, ideal would be 1-to-1. One input to one output. Number 2 would be least inputs plus outputs total. Preferring using change. And the question is, how do you calculate that? Because, again, this is one of those things where, as a human, it's fairly intuitive. But I think there's actually more steps to it than it would seem. Because if my goal is to give you the least amount of change that I can, well, obviously... matching up as many 1-to-1 is a good strategy. And then if I say, well, if I have a 50, it's obvious that I got to break a lot of change for that to go into 20 cents. But if I have 2 dimes, then I won't have to break a lot of change to make 20 cents. So in that case, I would maybe prefer even 10 pennies. But then you have to do it for each amount, so you have to compare for each amount. If I use... How would you do this? Man, this is... I don't know why this feels so challenging. Maybe it is that challenging, or maybe I'm just not that smart. But... Because how would I do that? If you presented me with, give me the optimal change, then matching up all the ones straight across makes sense. But then maybe it is kind of a traveling salesman's problem. I don't know. Because if I got some lesser change, then I basically need to say, okay, if I add some lesser change, do I still need the next biggest change? How much would the next biggest change... Is the next biggest change big enough? Just, man, this feels kind of tough. Or... Yeah, I guess I just need to see it play out. Anyway. Okay. So what I can say is if we don't have a good match of change, then I want to probably start at the largest values. And if I do have a good match of change, then I probably want to start at the biggest values. And in any case, I want to remove the values that I use. Okay, so I'm going to say I've got an array of matching inputs. So I've got a bunch of outputs. And for each of the inputs, I wonder how this works. Can I change the array How do I handle this scenario? Okay, matching inputs. I think I actually want somebody with a bigger brain to help me with this. Or a different brain. All right, matching. Okay, so for this one, what do we want? We just want to reverse the inputs. And then we want to say for let input of inputs Okay. Okay, stamps. So has enough is total in. It's greater than total out. Well, let's see. Okay. What's next here? So if that has enough, then break. It shouldn't be possible at this point for total end, because the worst, we just use all of them. Okay. We need to split these into inputs. Okay, so it actually is possible for after all of this there to not be enough. Because the fees could end up being greater. Okay, so if they're too small, then that's what needs to be done. Or maybe, I don't know. Okay, let me think about this again. Okay, it's not... Okay, I might have been doing the math on this a little bit wrong. So, it's not that the inputs themselves need to be denominated. Okay, I think this is actually a little bit wrong. It's that the total balance, the additional outputs, the change outputs. Let's see. Let me try this. Let me try this a different way. So this is not right. It's let's try this. So there's the fees. And then if we have to break that down, okay, I do need to go back to the whole idea of the splitting the fees. Okay, so let's go back. So there's this idea that we need two sets of inputs. We need inputs that do and don't match. I gotta think on this one as well. Okay, let's do this. We're gonna get denominated and non-denominated inputs. So we're gonna go through for let input of inputs. Okay, I'm thinking again on... So this might be another good case for a spreadsheet, actually. Okay. I don't exactly know what I want to put in this spreadsheet now, though. But okay, let me go back to here and think through it. Okay, so let's say that I have some values. I've got a 1 and a 2 and a 5 and a 0.1 and a 0.2, and they all have some stamp values on them. And then I have a 1.785. And I'm figuring out, I have some fairly random amount that I need to pay. 2856. And I'm trying to figure out, okay, these are my denominated coins here. But then this one, let me put my amount that I need to pay is over here. But then this one is going to get split. It's going to become 1, 0.5, 0.2, 0.05, 0.02, 0.01. Point 0.002, 0.002, 0.001. Okay. Now that's going to take 9 inputs. So if I want to use this, its cost is going to be okay, and what I'm trying to pay is this amount over here. And so this amount that I'm trying to pay, this amount is going to become... Alright, so let me move this over here. So this is the desired output, which would be 1, and we can go ahead and get all of these up to 3 decimal places. So this is going to be 1, and then 1, whoops. Ah. Okay, and these all go there. Alright, so 1 and 1, and 0.5, and 0.2, and 0.1, oops, 0.2, 0.05, 0.005, 0.001. Okay. 1, 2, 3, 4, 5, 6, 7, 8. That's going to require 8 inputs. So if I could take these values and let's say that cancels one out, that cancels one out. So canceled, 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 canceled. That doesn't actually make sense. What I actually need to do is I need to take this value and this value and subtract them. This minus that. Okay. And then what do I need left over in order to fill that out? And then I need to determine if this value is less than. So in order to get this to fill out, what I need is equals this minus sum of E. No, this is F. So again, so if I were to do it this way, this actually works out really, really well, because then I only need 1, 2, 3, 4, 5 inputs. So the question is, how do I figure out how do I figure out the best way to go about this? Somebody's got to have a better math brain than me for this sort of thing, because this is beyond simple business logic, and this is combinatorial logic, which is admittedly not something that I am great at. I'm pretty happy at the protocol layer. Oops. But here I'm actually a little confused as to, I can do it intuitively. I don't know how to describe the steps that I took to arrive at this. But breaking everything down is not the right approach. And let's say that this could have been wildly different. I'm not sure how to know ahead of time if this actually ends up being good or bad. But let me just try something else. Let's pretend that my number is actually, let's see, we're going to call it 23. Let's say that my number is actually 1999. So then I need 0.5, 0.3, wait. Zero point 0.05, 0.005, 0.002. 1, 2, 3, 4, 5. 1, 2, 3. Okay. And let me go the other direction. Let's say it's 1.1. I want to try 1.1 and 1.111. Let's do 1.111 first. So I need a 1 and a 0.5 and a 0.2. 0.02, 0.02, 0.005. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. But it does seem like, it seems like my best route is almost always going to be to try to use change the random numbered this is kind of revelatory. Revelatory? Relevation? Revelatory. This is kind of revelatory. But I don't know exactly how to... I don't know how to describe this in code, is the problem. I don't know what I'm discovering. Alright, so if we wanted to break this down, it's going to take 1, 2, 3, 4, 5, 6, 7, 8. And in the worst case, 1, 2, 3, 4, 5, 6, 7. So by having something of kind of a mixed value, along with some stuff of a well-known value, I'm almost always going to end up with fewer coins, it seems like, I have to spend. Alright, I want to try the one. There was one more that I wanted to take a look at here. And what if that was just 1.1? One, 2, 3, 4, 5, 6, 7, 8, 9. Versus 1, 2, 3, 4, 5, 6, 7, 8. That doesn't quite make sense, though, intuitively. Carry the 1. Got it. Okay. So what conclusion can I draw from this? I think it's just that I can try different combinations, and it seems like there should be some sort of function that there should be some sort of shortcut function where I don't have to try all of these different combinations. But I think I do. I think this is a variation of the traveling salesman problem. And so the only way to know what the optimal amount of change is, I mean, we can take a guess. But really, the only way to know what the optimal amount of change is to just take some inputs that can add up to at least the amount, and then try them in various orders. But I'm thinking there's probably a shortcut in this sense of breaking it down into the individual. So what change would this produce versus what change would this produce? If we break it down that way, then it seems like we should get our answer of what's going to be left over. So let me just take a look at that. So again, the 1 cancels out, the 0.5 cancels out, the 0.2 cancels out, the 0.05 cancels out, and then the 0.001 cancels out. That is essentially doing the subtraction to say, okay, now what's left over? So we would still need 1, 2, 3, 4, 5, 6, 7 coins. Is that right? So are we saying that, or is that not true? Because we could, is there any other way that we'd knock this out? We can't knock out that other one except by bringing in a 1. That's the only thing that we can do to knock out that 1, is we have to bring in a 1. So that one we can't get rid of. That one's stuck there. This 100, could we combine any amount of something else to get the 100, or the 100? Okay, so maybe we take the things that cancel out. Maybe this is the strategy. We find what cancels out, and of what's left over, let's add what's left over. So I'm going to do this plus this plus this. That's what's left over. And then over here, I can say it's this plus this plus this plus this. But is this any different than just doing the subtraction on it? Because then I could just say this is equal to this minus this. And that's exactly what I'm left at here. And then what I'm left with of that is this. So does that give me any shortcut? Does a shortcut emerge out of this? Of saying, these are the pieces that are left over that have to be accounted for. Yeah, I think that's essentially no different. I don't think that this is faster. I think this is slower. Okay, so we take... Okay, what if we're doing 2 of them, though? If we're doing 2 that are kind of random numbers... I think the amounts, it doesn't matter. I think we're going to end up with the same results. I need to turn the heater on. It's getting kind of cold in here. That wind is a little more powerful than expected. Okay, so the question for a math brain is there a shortcut that can help me find the best match of coin if I'm mixing in coins that are not denominated yet? And I think the answer is no. Just denominate everything. It's going to be a crapshoot. On average, it's going to be same distribution. Okay. All right. Well, let's carry on. But I think it is just as well to try to pull those in, the non-denominated amounts. Especially if they're low. Here's another thing, is that when we're doing payments, we could also do a request to say, hey, these are some denominations that I want to send. If anybody else has denominations in common with these, let's send them in together. We'll send them to their various outputs. So that's something that we currently can't do. And that's beyond cache-like, though. That is a mixed send. The idea that I would just post, here's a bunch of output targets that I want to make. Does anybody have similar output targets that they want to make? And then we just throw stuff in. So the payment is, I'm paying to one or more contacts, you're paying to one or more contacts, but the result can't be determined whose were the inputs and whose were the outputs, because it's mixed xprivs in and mixed xpubs out. That might be better to worry about than this. And that should be pretty easy to do. And really, I don't even know if it matters if the scales match. Okay, anyway, going on. Alright, so non-denominated inputs. Okay. How's it going, everybody? Can we get a math whiz in the channel? Where's Joker Jake? Can we get him back? I need somebody that spent more of their brain power doing combinatorial logic to tell me, is this the traveling salesman problem? Is there a better way to go about solving how to match up denominations of digital coin that are... I think it's not the traveling salesman problem, I think, until we put in things that don't actually match. Then it starts to become the traveling salesman problem. If we put in something a coin that has a random value, or if we're trying to find, if we don't have enough denominated coins to easily reach the value, then it starts to become the traveling salesman problem, because we just have to check and see if we use this coin that's too large and we have to break it down, how many additional addresses do we end up with, versus if we just accumulate smaller coins, how many additional addresses do we end up with? And maybe that's the way to go for that. Maybe we go one step larger and see what the number of addresses needed is, and then we go, and then we continue smaller, and we see if going smaller yields fewer addresses, and then if it does, then we take that. Or I guess we could take the remainder, we could break it down, and then we'll know. Well, we won't know. We won't know because it wasn't a perfect match. Yeah. Hey, ForGod, how's it going? Hello, hello. Can you solve this problem for me? I'm trying to figure out. So we have. I'm trying to figure out how to give back optimal change when occasionally, so imagine a coin machine, and I want to give you back optimal change, but occasionally either I need to break change for myself, because let's say that you need back a 5 and what I have is a 50. And so I have to break change for myself first. And the question is, how many addresses does it require for me to break the change? So if it's a case of 5, I want to give you back 5 and I have 50, then that would mean that I would need to break 2 20s and 2 5s. So that's 4 addresses that I'd have to break. But if I also happen to have some 2s and some 1s, I don't have any 5s left, but I have some 2s and some 1s, then I could get 2 2s and a 1, and then I'm only using 3 addresses. So my optimal path would be to use the 2 2s and a 1 in order to break the change. That's kind of the question. Trying to figure out essentially that. And there might be some more nuance to it. Shudder. The word nuance. But there might be. Anyway. All right. And then we also have a color coin problem, because if I break the 5, or if I break the 50, then basically each one of those is kind of the same color, because they came from the 50. But then if I add 2 2s and a 1, that might actually be worse, because they might be of the same color, or they might be all of different colors. And so it's better to have fewer colors. There's multi-dimension. This thing's multi-dimensional. I need somebody with a bigger brain to help me out. I know just the guy. I'm gonna text him. Oh, you tried to follow. Basically, I'm trying to determine if there's a shortcut to figuring out what the best number of addresses and amount of change to give back is. So the goal is to not give back any change, but if we do give back change, we want to give change that's denominated so that it's not distinguishable from whatever so that you can't look at it and say, yeah, that's the change value. So it's pretty clear, or it's so that it's not clear which is the change value. That's what we want to do. The ideal is no change, but also it's the number of addresses. But I do know the guy. I do know the guy I need to reach out to. I know a guy whose brain is about 10 times bigger than mine. This is a guy who basically, could look at a Rubik's Cube, close his eyes, and then just play with it and have it come back. He's, very high IQ, recognizes patterns very, very easily. I'm going to send him an email real quick. Let's see if I get his phone number, actually. Hey, I've got a math problem that's to solve. It's too big for my brain. It may be a traveling salesman style of problem. So maybe there is no optimal solution. But I was wondering if A, this is still your number, and B, whoops, if I could possibly contract it out to you, or at least get a phone consult. Wait, you could help, but it would require me being patient? What? What? How do those two go together? But explain to me the patient part. Patient as in it would take you a while to understand and I have to re-explain the problem multiple times? Or patient as in it would just generally take a long time to do? What kind of patient are we talking about? I can maybe swing something. All right. The former. Okay. All right. I'm going to practice my best patience. I'm going to breathe in the wind and the fiberglass along with it, and I'm going to bring my best patience to the table. So, how do we do this, ForGod? Do you want to get on a chat? Do you want to do text chat? I could loop you into a Jitsi here. I've got just the Jitsi. All I got to do is click a button and I could get your audio in here. You let me know. You're in the Discord already. I meant a voice chat. But we could do the Discord. Alright, you just lurk so you be busy. Right. Let's see. But yeah, if you want to join in on Jitsi and be live, I have a Jitsi link. I can send it to you. You just let me know. Alright. Okay, so we're going to split these out. Maybe it doesn't matter. Maybe I don't need to split them out. I was thinking I should split them out. But we need other logic here for mixing or something. Maybe it just doesn't matter. Maybe it just doesn't matter. Okay, let me assume that it doesn't matter. Well, no. I need to know a little bit because all right, well, let's go back to this. We actually don't need matching inputs at all. The whole idea of the matching input was a red herring. What we need is just fewest inputs. Well, okay, I guess here's the thing. Here's why the non-matching inputs would be good. Because we could get rid of them, and then we do have a guarantee of what it takes to get there, and that we don't. We don't have a guarantee that we can get there because we don't have a guarantee that we have those coins. So, it's a mixed bag. Okay. Sending the link. If I can find you. Well, the problem is we're not friends. Let me see if I can message you. Oh, now you send a friend request. Okay. Where can I find friend requests? What, the letter O? I can't find you. I just saw a little notification pop up saying there was a friend request, but I don't see it. Oh, there it is. Starting up virtual camera. Sent you the link. Do. Maybe I just do this the old school way for now, since I really don't know what I'm doing. Headset, no webcam, no problem. I won't show you. I mean, I could if you wanted me to, but just join in. I hear you. What's up? I'm doing good. All right. Okay. 1 second here. All right. Now I've got your audio connected to the stream too. Can you say something real quick?
Hello.
Okay. Now the problem there is it took it away from my headphones.
Oh, okay.
So, and I will turn off the music. There we go. Okay. Yeah. So the problem that I'm having is, are you familiar with the traveling salesman problem?
No, I'm familiar. I don't remember what it is. I've heard of it before, but I forgot what the premise is.
It's basically you have to visit a bunch of, it's the airport problem.
Okay.
It's you can't find an optimal route from one city to another city because there are so many different flights going on and there's so many different price fluctuations that it's not possible to find an optimal route because you can never know on any given day with all the weather conditions, with the pricing conditions, et cetera, what an optimal route is going to be. And so in order to make flights work, They basically just kind of do some guesstimates and then kind of put forth a best effort, but it's just not possible to calculate if you need to travel to a couple of cities and back in what order you should visit them or what's going to be the most cost effective. It's just because it's the number of permutations is just becomes too high. So the
Okay.
airports select a couple of routes and then they just go with it, and that's that. And I think that this might be similar because the problem is I have to pay an amount that's a random amount. So I'm going to want to
Mhm.
pay somebody 2.783 dash. And that amount is, for all intents and purposes, random. It's hard to know what amounts someone would pay because you pretty much have an infinite number of amounts,
Mhm.
or at least a few million different amounts that would be common if we could just say, all right, leave off all of the trailing digits on dash. So if I want the goal with a cache like send would be to reduce the number of inputs and outputs in the transaction, because those are how those all of that goes onto the blockchain, and so all of it is public information. And so the more inputs and outputs you have in any given transaction, the the easier it is to forensically look at it and then determine where the inputs came from and where the outputs are going to. So ideally, you would like to have zero outputs going back to yourself.
Okay.
And you could think of this in terms of coins. So in the real world, you don't give somebody back a bill that is worth $1.87. In the real world, you give back $1, 2 quarters, uh, 3 dimes, a nickel, and 2 pennies.
Hmm.
I don't remember exactly what number I said. I think it was $1.87.
Yeah, you said $1.87. Yeah.
Yeah. So you have a finite number of combinations that you can arrive at given any value.
Hmm.
And so what I'm trying to figure out is I don't so I do first of all I don't I know what denominations will work the best. Just historically it's going to be doubles, wholes, and halves. And so
Hmm.
that's what I've decided on. So there's the 1, the 2, and the 0.5, which effectively that's the 1, the 2, and the 5, because the 0.5 of the next increment is the 5 of the previous increment. So out of 1, 2, and 5, that seems to be the three numbers that if you have them at each scale, then they will give you the fewest number of inputs and outputs on average. I think on average it's slightly less than 2. So in the real world though, there's going to be a mix of denominated and non-denominated cryptocurrency coins. So most cryptocurrency coins are just random numbers, and that makes them highly unique and highly identifiable. So I want to use these denominated numbers instead. And that also means that I don't have to give change back to myself, because you can give me any value that you want to receive, and then I can give you that value out of coins that are denominated in those amounts. Does that make sense?
So you said, so for what I understand so far is you're trying to reduce the inputs and outputs on the transaction, and you ideally you would like zero outputs going back to yourself. I caught that. You want to work in doubles, wholes, and halves. Those are the denominations you said would work the best, and you just said that you want to give back. If you have to give what cash back, I forgot the. I didn't catch the last part you said. I was trying to.
So yeah, we want to eliminate the change that you get back to yourself if possible.
Mm-hmm.
And so if you think of it like a cash drawer till at a store,
Yeah.
you've got a slot for tens, fives, ones, quarters, dimes, nickels, pennies.
Mm-hmm.
So when that pops out, but you don't actually have a guarantee that you will always have the enough. Occasionally, the ideal thing to do would be to give somebody a 10 and two ones, but you may not have a 10, so you might give them two fives and a 1 and 4 quarters.
Got you. I understand. Okay.
So if you knew exactly how many coin, if you knew that, let me try this again. If I can take any given amount and I can tell you what the ideal change would be, but then I have to compare that to what I actually have, which may not be what the ideal is, and then I have to figure out how to get there. So if I don't have any tens, but I have fives, then I need to build up the change with fives. But one
Got you.
thing that I want to avoid doing, because we're trying to minimize, it's a trade-off, and we're trying to minimize the number of inputs and outputs in aggregate. If I had 100.1s, it would be better for me to break a single 100 into 10 tens than to aggregate 100 ones into 110.
Mm-hmm.
Or 100.1s into 110. Does that make sense?
Yeah, yeah, yeah. That makes sense.
So that is the issue that I'm trying to wrap my head around. Is there even an optimal solution for this? Because there may not be. Because I keep on thinking about it, and
I'm just well, just first off, I'm thinking why wouldn't you be able to just think just start with what's the biggest like denomination that you have available, and then just go from there. Why can't you just do that?
because that might be 1,000, and it would not make sense to break 1,000 down into hundreds and tens if I have a 10.
Okay.
So the denomination, so I've got the list here, and it is arbitrary, but it is what seems to be, let's see, 1,000. Do I have a one? Where did I? Oh, here we go. Right here, denom amounts. So 1,000, 500, 200, 150, 20, 10, 5, 2, 1, 0.5, 0.2, 0.1, so on and so forth.
Mm-hmm.
So if I had a 200, but what I need to pay is 10, I want to try to pay a 10 if I can.
Yeah.
And so that's where it's a little confusing, because it's like I have to try both ways. I have to say, okay, well, try to find the smallest value that's above the value that I need.
Mm-hmm.
But then even that is difficult, because the value that I need to send is going to be essentially a random value, like 12.251. So I can break that down into denominations, but if I have a 10 and a 5, that will work. For 12, I would just make more change, but I would prefer to not make change if I can. So I'd prefer to get a 10 and a 2 and a 0.2 and a 0.05 and a 0.001. That would be the most preferred, because then I can eliminate giving change back to myself. Well, potentially, because the other problem with that is that if there's too many coins, it's this optimization problem that I don't know how to write the algorithm for the optimization. It's
Okay,
because
I
you're
see.
you're you're trying to determine, and it is multidimensional. There's really three dimensions to it. The third one we don't need to worry about right now, but the third one is basically what I call the color of the coin. Because any coin that's been used in another transaction together is colored with that transaction. And so you would want, I think what you would want is to try to avoid using, well, it depends on what you want to do, but you'd want to avoid trying to use coins that came from the same transaction, so that any transaction is, well, either as monotonous as possible or as multicolored as possible, depending on what you're trying to do. But you basically, being able to trace back where things came from, you want that to, you want it to be as cash-like as possible. If I give you a dollar bill, you can't look at my dollar bill and figure out who else has had their hands on it. I mean, I guess you could if you could lift fingerprints off of it, or if the serial number has been tracked as it's been moving through the system. But a dollar bill is just, you're just exchanging value. You're not exchanging information about the person that you're exchanging with. The problem with cryptocurrencies is that because of the public ledger and because of all the cryptographic signatures, you are inherently exchanging information about people with every coin. And that the goal is to make it more cash-like,
Got you.
and
Okay,
to
okay.
not to exchange as little information about the people and only communicate the value. And
Got it.
it's kind of a brain busting problem, and there's a lot of, it seems like there's a bunch of trade-offs.
Yeah, that last part sounds like we got to think about that a lot more. But with this problem that's in front of us now, I think um so yeah, there's definitely, I feel like there's definitely an algorithm for this. I'm trying to think what would it be. I don't understand how there's definitely an algorithm for this. I just have to think about it somewhere. It's definitely has to do with something about like I like how I like what you said at first. You said grab like the number that's the second, or the number that's I guess the second largest or something like that. Like compared to the amount that you're trying to, I guess, calculate. So like for example, like you said, like you had like the 12.5 whatever example. You said like grab 10, and then if you have like a 10 and a 5, then you can grab the 10 and then grab the 5, but then make change out of the 5. I think the problem comes in though. You said like you don't know, you don't want to have to make change if you don't have to. So I'm trying to think.
Yeah, that's where it's combinatorial logic, because a 10 and a 5 can work, but a 10 and a 2 could work if we, and so it's like, if I take a 10 and a 5, how many addresses do I have to make if I use a 10 and a 5? Okay, but if I use a 10 and a 2 and then some of the other change, how many addresses do I have to make? But I need some sort of hard stop on not trying to aggregate really small values, because this is the problem currently with CoinJoin and Private Send, is that the algorithm that's used tend towards producing really, really tiny amounts. Tiny amounts that are so small that they're not usable, so you end up needing hundreds or thousands, well, tens, typically tens, not uncommonly hundreds, and I don't think usually thousands. But if you had enough of them, if you'd been using it long enough, you would just accumulate thousands of these 0.001 values. And so we want to avoid that. We don't ever want to be in a situation where, because it always, that's what the current algorithm, it always prefers the larger coins, because it always prefers the smallest number of transactions,
Mm,
regardless of all other criteria. And the problem with that is that then you end up with hundreds or thousands of these little 0.01s that are useless.
Yeah.
And then in order to join them back together, because they've basically become change from all these other transactions that you've done, when you join hundreds or thousands of them back together, or even when you join a few dozen of them back together, then because of all the cryptographic signatures, it reveals information about all previous transactions that you did. So then you can trace any transaction where one of these was the result of a 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 transaction, but you have enough of them, and then it combines it all back together, and then it retells the story of where it came from and what the other how the other transactions were related. So you want to keep essentially the number of coins that you want to send on any given transaction should be less than 10 total as inputs.
Got it.
And ideally, you want 0 outputs back to yourself. Now, with the system that I've outlined here, you'll almost never get back 10. That would be a pretty big number to get back. Because I was just doing a spreadsheet earlier, and I was just kind of playing around with it and seeing, okay, let's just take some semi-random values and say, if I had to, if I break this down, what does it look like? If I were to take some mixed coins, what does it look like? I'm trying to find a pattern of how do I predict what coins will be the best coins to use without literally just going through every possible combination of coin and then calculating it together. I'm looking for some sort of pattern that says, yeah, if you take this number and take this number, and then, I mean, you've maybe heard of these tricks before where you can take numbers, then add each of the digits of the number together, and then if the thing is divisible by 3, then the whole number is divisible by 3. There's these little shortcuts where if you can find this pattern, then without having to go through a bunch of combinatorial logic, you can quickly ascertain, yes, this matches, or no, this doesn't match, and then move on. But if you have hundreds of coins and you're trying to figure out the best possible combination of coins, then that actually really quickly becomes an exponential problem that takes a long time for the computer to just sit there and try every permutation. I don't know if that's really the problem here. Maybe it could run through every possible permutation of coin and change, and it would be just fine, but you're going to have hundreds of inputs, and or potential inputs, not inputs that actually have to go in, but source coins. You typically in your wallet, you're going to have hundreds of source coins to choose from.
Mm-hmm.
And so intuitively, it just feels like that would be a pain.
Yeah, that definitely does sound like it'd be a pain. Okay, so I'm looking at this graph. So where it says like was it cell E18 at 1.071? That's what.
Oh, whoops, sorry.
Sorry, my fault.
What?
No, you good. So is all you're doing on the right, or like in that E column, or cell E18? Yeah. So that 1.071 is just being broken down into like one, like on the left column is being broken. That's like the smallest number of inputs to come up with 1.071. Like,
yeah. So what I was saying is, so you're going to have in your wallet, you're going to have a mix of denominated and non-denominated coins, because you're going to have a mix of traditional transactions that are fingerprinted, and then you're going to have a mix of these modern transactions that are not fingerprinted and that are denominated. And so what I was looking at here is, well, if I just take some random value that I have, so say I need to pay this, and I have a non-denominated value of this, then my remainder would be this. And the question is, would it generally be better or not better? But is there a way that I could find a pattern to predict, with any given number, how many additional inputs are going to be necessary? So with this one, if these are the two values, if I happen to have a coin that represents this value as a whole coin, which is a non-denominated coin, then the change that I would have between these would be this much. So I would have 1, 2, 3, 4, 5, 6 inputs. And that's actually pretty favorable because if I wanted to break this down individually, I would need 1, 2, 3, 4, 5, 6, 7, 8 inputs. So if I were
Mhm.
to use this value, it happens to work out better. And then on average, it seems like if I were to use a value that just kind of has, if I were to mix non-denominated coins with denominated coins, it seems like on average, I would actually do better to mix in the non-denominated coin. So if I have, this random value and I have some non-denominated value that is close to it, then assuming that I have but then this is where the problem comes in, is this only works if I actually have each of these coin values. So I know
Oh yeah,
what
yeah, yeah.
they would break down into, but I don't know if in my wallet at any given time if I actually will have a 0.05. And so if I don't have a 0.05, then I have to go find the closest thing that I have to a 0.05 that either makes it up. So I either have to go down and say, what can I add together to get this? Or I have to go up and say, what change would I have to break to get this? And then I have to calculate that in with the number of inputs and outputs that I'm dealing with, and then have to decide, is that actually a net positive? So as I'm just looking over this, I'm thinking more and more that there may not be, that this is the same vein as the traveling salesman problem, where
Mhm.
at any given time you don't know if this route will actually go to that route on that day. You don't know whether this coin will actually exist when you break this down into that denomination. And so this may be a problem that actually doesn't have an optimal solution. It may be a problem where the only solution to find the optimal solution is to literally try every combination. And we'd have to make a compromise. But can we make a compromise where we don't end up combining 20 0.001s? That's that's
Yeah.
the that's the thing, is if we can find a compromise where it's like, okay, we're not going to guarantee the optimal value, but we're going to guarantee that we don't have suboptimal
Mhm.
situations. We're going to guarantee that we never accidentally give you 100 addresses when we could have given you 12, but we're not going to guarantee that we give you 10 instead of giving you 12.
Yeah, that's tough because now that I understand the problem a little bit more, I think your first intuition was right. It's basically saying how you were explaining how since it's random, or like the amount of coins or like the amount of coins one and then the two, like if you're gonna have non-denominated and denominated coins in your wallet, like at any given point in time is gonna be random, and then so trying to calculate what the optimal, I guess, like route to come up with the amount before that transaction is gonna be kind of tough. So I think it just depends. I think I think it, yeah, like you said, it depends on what's in your wallet. But if you have like what you said like 0.001 in your wallet, like multiple, I guess like a large amount of 0.001s in your wallet versus like having bigger coins, then like that the time that it'll take to, I guess, merge all of those together would be kind of not ideal at all. So I guess coming up with a solution, like you said, that guarantees that it's not gonna be a suboptimal calculation, I think was probably the best way, I think, to address this. But then also trying to think of what that solution is at the same time, I think it's kind of tough too. I'm trying to understand how to even get to that point.
And
Uh,
I think part of it is that the wallet needs to tend towards producing coins that are usable. So it can't tend towards always breaking change down smaller, because then it will tend towards dozens or hundreds of coins that just aren't really that useful.
Mm-hmm.
So there has to be some sort of balance where it's, yeah, like I said, it's not always trying to choose the absolute fewest coins, because if it always chooses the absolute fewest coins, then it's going to pile up on the low end. The smaller the coin value is, the more you're going to get, and the less likely you're going to be able to use them. So it,
Mm-hmm.
it has to occasionally say, I could use a 1, but I'm going to use a 0.5 instead. I could use a 0.5, but I'm going to use 2.2s and a 0.1 instead.
Yeah.
And I don't fully understand what that needs to look like, but I think that somebody who who's done, and this is why I thought you in particular might have a good solution, because I believe you've done some statistical modeling, and if you've done some statistical modeling and you've done work with graphs, then you might know, here's a graph algorithm that will, within the X number of iterations, give you a result that is in the 90th percentile. And that would be kind of what I think I'm hoping for, is something where if you were to look at it as a human, you might be able to intuitively say, that's wrong, you should put this here and this here, and then that will work. But that as a computer, you could at least guarantee that it's in the 90th percentile within a certain number of iterations of trying, and then at the 10th try or whatever, you just say, okay, this is good enough for a computer that doesn't have intuitive pattern matching, because it's going to produce a result that's good enough more than 90% of the time.
Yeah, got it. That is true though. I did do some statistical modeling back in the day because that's where my degree is, in statistics. But I haven't taken graph theory in a while. I'm trying to think. All right, so let's see. Yeah, coming up with a. Hold on, let me hit Google real quick. Let me see if I can find like
Okay. And I'm going to,
algorithm.
and it's good just to talk this out, just to kind of, yeah, just to get it more clear in my own head, because it's just problems that are cyclic. They're still hard for me to solve.
Yeah. That's what you've been working on. Like, were you working on this last week too? Because I think I saw you go live last week. I just wasn't.
Yeah, last week I was, but I was working on it from, I only worked on it, I think, one day last week, and then I worked on it the past couple days, and there was a week before that I worked on it a bit, but I was working it at a different angle. So figuring out, I mean, it's pretty easy to figure out, okay, here's a value, what's the ideal change? It's hard to figure out, here's the ideal change, here's what I actually have, what's the ideal change out of that?
Hmm.
And that's what I'm trying to figure out now. So before, I was just, I was playing around with
There's
the
definitely an
easier
algorithm.
side of it.
Okay, got you. I understand. There's definitely. I feel like there has to be some type of algorithm to figure out what the ideal change is given what you actually have. Like that has to exist. It's just a matter of figuring out what that is and then translating it into the code that you write it. What?
Yeah, I
Um.
I think it's going to be a variation on one of the traveling salesman graph problems, where we would say you're going to construct a graph and you're going to have so many nodes of such a value per each node, and you're going to walk down the graph, and you're going to try to pick from this node. And if I think it's going to be somewhere between kind of like a maze problem, where in gaming they have weighted mazes, so you can go through the hill. If you're playing a game like Age of Empires, you can go through the water or you can go over the mountain, but it's going to cost you a lot more energy. And so the game tries to calculate, should it send the soldiers across the bridge that's 10 tiles away, or should it send them across the water that's going to cost them 3 turns? You know what I'm talking about? I think that's in the realm of that type of problem, because one of the dimensions is how do we use it is tough, because if I need to somehow detect if there's too many. Well, I guess for the first iteration, part of my problem is I'm getting stuck on optimization problems, because in essence that is the problem that I'm trying to solve. I don't feel like our current quote unquote private send, I don't think that it actually has much to offer. And based on my own experience with it and the experiences of others, just about everybody I've talked to have the same problems that I have that I'm mentioning. And so I don't really need to solve that problem in order to get this done, but I do need to solve that problem in order to solve the overarching problem, because there's no need for me to create an alternative system of denominated coins if I can't prove that the output on average is going to be significantly better than our current system of private send.
Yeah.
And I intuitively, I dare to say I know that this is better. Well, even just, I did put some stuff in spreadsheets, and I just kind of looked at what each digit. I think that I came out with, if you do denominations this way, then the number of addresses is slightly less than 2 per digit. Or it was either slightly less than 3 or I think it was slightly less than 2. I think that given an even distribution, and then given, or maybe it was slightly more than 2. I don't know. But I ran it kind of 2 ways in a spreadsheet, looking at what if it's an even distribution and what if it's a natural distribution. And in both ways, it's far more favorable to our current implementation. But if it ends up with the same problem, even if on average it's better, if it ends up with this problem where sometimes you want to do something and your only way to do it is to put in 100 addresses, then those instances offset it being better on average enough that it just may not be worth going down that path. But the other thing is that as this gets used more and more, the problem becomes easier and easier to solve, because as your inputs and outputs on average tend towards denominated inputs and outputs, then your coin usage on average tends towards lower. So it's a system where at the start of the system, I think it's better than our current system. And as the system grows and expands, it will continue to get better with more adoption, which to me, that's an ideal system. An ideal system is if one person uses it, it benefits them. But if 2 people use it, it benefits them more than just, where you get synergy, where the more mass adoption you get around the system, the better and more efficient the system becomes. But it doesn't require full mass adoption to work at all. And I feel like our current system, it requires full mass adoption to work at all. If it's not over 50% of Dash users using private send and coin join the way that they're currently implemented, then it just basically doesn't have any effect. This, I think, even if you're just one person using it, you could start to get value out of it pretty quickly.
Got it. Okay. Okay.
So,
Let's see. Man, guess what? I'm pulling up Chat GPT real quick. That's
oh no. Oh no.
Let's see about these. I'm about to ask it to write like some type of what's the like determine the total amount of change algorithm given given what you have. Just look at it and hopefully that sparks something in my brain.
I would say instead search for possible solutions to mazes. What are algorithms for solving mazes or algorithms for solving the traveling salesman problem? Because the ChatGPT is going to be trained on data that's most readily available, and the most readily available data for change problems are simple interview problems. And so it's going to give you back. I mean, you try it, but I
Mm,
think that using the this route, it's not going to give you back good answers because it's going to find more things on Stack Overflow and on various sites that are related to homework and interview problems dealing with using mod, because that's typically when people bring up problems of change, what they want to test is your ability to do division and mod and remainders. They're not testing your ability to do algorithmic graph algorithms. So that's why I say if you prompt it with the traveling and the maze solving, I think it's more likely to come up with relevant graph algorithms. But you try it both ways and you see what yields the most benefit.
got it. Solving a maze. There's hold on. Let me look at the maze algorithm. I know there's backtracking, there's depth first search, all of that. Let me see.
Yeah. Well, there's one of the simpler ones is called A star. The problem with that one is that I don't think that would be suitable to this because here we're dealing with weighted areas of the maze, if you will.
Mm,
Whereas A star is just looking for open paths. The path is open or it's not open. And I think the better algorithm would deal with weighted paths. Like, so one dimension of weight would be the further away I am in uh, the further away I am in magnitude from the desired value, the worse the weight should be. So if I if I have to go up to 1,000 to get a 10, or I have to go down to a millionth to get a 10, then the 1,000 I think is actually closer. But if I have to go up to 1,000 to get a 10, or I have to go down to a tenth to get a 10, then equally they're equally far apart, but the 1,000 is better because the 1,000 will have fewer pieces overall. So there's the distance is part of the weight, and then the number of pieces is part of the weight.
got it. Okay. Um,
And I'm gonna go back through this and see.
I remember Dijkstra's algorithm. I'm looking at this again. This, um, so could this just be as simple as like setting up some type of graph, or some type of weighted graph, given the amount of inputs that we have, um, or what we have in our wallet versus what we need to actually um like create, I guess, like the value we need to create from what's in our wallet, and then just uh running like a maze algorithm on that, and then seeing if we can, or what like the shortest path is to get to that, or not the shortest path, but I guess the most efficient path to get to that value.
I think something like that could work. And if you had an inkling of how to prototype it in any language, I have no doubt that we could make a dash task for you to do it.
Okay, I think I could do this in Python, honestly.
If you could do it in Python, I can certainly translate it back to JavaScript. If you're kind of familiar with that and your brain space has already been there, and you just need a couple of joggings to of the memory to get it to come to the forefront, then you may be a better person than me, because I have done some of the graph algorithms, but I've only done them for interviews and homework. I have never done it in real life that I can remember. And I never took statistics class. So there's an element of this that I feel like someone is much better suited for than me. And so it may be better for me to just pick a dumb way to do it, finish this out, and then evaluate more later. But I guess I kind of needed to get to the point of understanding that this is, I don't know. I guess I just felt like there was a simpler solution, one that I could just kind of hack together, but I don't think there is.
Yeah, I don't think there is either. I thought there was at first when I was originally just tuning into the stream and watching you kind of hack away at this, but now that you explained it to me in a way that I wasn't understanding at first, I thought it was just at first just like you just take the biggest like coins or whatever that you have and then just like add them up and then you send it off. But then you explain that we could have denominated coins and non-denominated coins, and that I think switched it up for me. Like, um,
Yeah,
so
but even the the denominated versus non-denominated, I don't think is the biggest issue, because we could always pre-denominate the coins. That is something that we can choose to do. We can say you can't spend non-denominated coins. The problem with that is that if you are going to denominate a coin, you are guaranteed a certain number of addresses that coin is going to produce. So if you can use that non-denominated coin together with other coins that you have and produce fewer addresses than what the non-denominated coin would require to denominate, then you're actually better off. So that's kind of the metric. Is there, I don't think that there's a situation that would run counter to that example. If we can use the denominated coin and end up with fewer addresses than if we didn't use the denominated coin, considering that the non-denominated coin, considering the number of addresses that would be required to denominate the coin, then I think that we're better off. So there's a number of things like that, but it just feels like in order to really get the right value out, it just feels like we'd have to try every combination. And even if that's true, that's not so bad, because there's only going to be so many coins total, and where they're denominated, you know what the values are, so you don't need to try every single coin. If you have 1,000 coins, but they're put into buckets where 100 of them are 0.5 and 100 of them are 0.2 and 100 of them are 0.1, and so on and so forth, then you don't need to traverse the 1,000 coins. You only need to traverse the buckets. And so by denominating the coins, we have fewer buckets overall. So even if you have, let's say, I think it ends up being something like 13 denominations, and then you have non-denominated coins that give you another, 20 denominations. You could still, I think, write an algorithm that would be far better than having hundreds or thousands of denominations, because you can significantly improve it just by having half of your coins denominated. That logarithmically takes down the number of permutations that you actually have to deal with. And so if you were to say in your iterations, we have so many coins that are between this denomination and this denomination, we're going to pick one at random and we're going to try 5 different coins at random. That I think would be an acceptable solution as well, where we don't try all 100 coins, but we try 5 of them and we pick the best of the 5. And again, given a somewhat even, somewhat natural distribution, if we just pick 5 and our denominations are between wholes, halves, and doubles, then in between the variance of the 5, we'll probably find one that's in the 90th percentile of the entire group of 100 that is in that basic range. Does that make sense?
Yeah, that makes sense.
Yeah. So because you could somehow get a set of coins that are the worst possible set of coins where they have the most possible variation, but that's not really likely if you just pick 5 at random from however many. So yeah, so that would be pretty decent too. I just want some sort of algorithm that will actually... I don't feel like I'm the right person to invent the algorithm for the selection myself at this point. I think I should go the stupid route, finish this out that way, and then come back around to it with something else that someone with a bigger brain than mine, or at least more experience in that area, comes up with.
Got you. Okay. I mean, I could take a shot at it. I think with Python or something. I'm just trying to think through it already, but I think it could if I just construct the graph and then traverse it and then return like what we want. Return we want like we don't necessarily want. Remind me, we don't necessarily want the smallest number of we would prefer to have the smallest number of inputs, but the smallest number of inputs does not necessarily mean that's like the most efficient way to get to that value, right?
Yeah, so there's a few different ways to look at it. We want the fewest addresses that come back to us, so the fewest number of change addresses. We want the fewest number of inputs, and we want to not tend towards creating small amounts of change that are difficult to use. So the balance is somewhere in those 3 things.
Got it. So fewest number of addresses that come back to us, fewest number of inputs, and we don't want to trend towards like the really small like coins, basically. Okay.
Yeah. So if occasionally, I mean, this could even be a roll of the dice kind of thing. If occasionally, hold on just one second. Hold on, my wife just called.
No problem. All right, I'm back. Grab some water real quick.
Okay. Yeah, so we occasionally want to use more inputs than necessary when the inputs are very small.
Okay.
So we probably never need to worry. So the more average a transaction is, the less we need to worry about small inputs. So if you think about it, We don't have an even distribution in the way that we use money. We will tend to use 10, 20s, and 5s probably more than anything else, right?
Mm-hmm.
I mean, you think about anything you do with other people, 10s, 20s, and 5s are it. You know, because
Mm-hmm.
it's just convenient not to have to worry about a 1. If somebody wants to buy a PlayStation game from you, you'll sell it for $15, or you sell it for $20. You're probably not going to sell it for $13.
Yeah.
So on the really high end, we just don't have a lot of things that cost $100,000. And on the really low end, it's just not really useful to get into the nitty gritty of how many pennies something is.
Mm-hmm.
And so we need to tend towards, I think we need to tend towards consumer to consumer transactions. So we need to tend towards using extra pennies, so to speak, where we can. Otherwise they build up. We don't want to have a penny jar. So if we have an opportunity to get rid of 2 pennies, we should probably take it. If we have an opportunity to get rid of two pences, we should probably take it.
Mm-hmm. Got it.
Because otherwise it just accumulates, and then we can't use it without it being highly detrimental to the privacy. But even in doing what we're already doing here, which is restricting it to 3 digits, that should help a ton in not ending up with super tiny amounts that can't be used. Because I think one of the problem with the current implementation of private send is it goes down. I think it goes down all the way to, let me see if I can remember. I think it can do 10001000, and then I think it can go all the way down to something like this. So you end up with tenths, hundredths, thousandths, 10,000ths. You end up with a lot of 10,000ths. And if we just cap it at thousandths, then that is already a lot better.
Mm-hmm.
And then when you're transacting with people that want an amount in US dollars, you'll end up using those thousandths because they correspond roughly to pennies. It depending on the price of Dash on any given day, it's somewhere between half a penny and 2 pennies. Or maybe it's even less than that, but anyway, you do have opportunities to use those up. You just don't have a lot of opportunities to use them up with consumer to consumer, because the lowest that I'm going to go with something that I'm selling or buying or whatever with somebody is probably going to be 0.01.
Mm-hmm.
And it's probably going to be closer to 0.1, because that's, I guess 0.01. 0.01 is probably where I'd normally draw the line, just because if one Dash is worth $50, then 0.1 is worth 5, 0.01 is 5 cents. I don't really have any need to go lower than that. I don't care about half of a cent, which is what this would be. Oh, sorry. No, 50 cents. Half of a dollar. And this would be half of a cent. No, 5 cents. Whatever. 50. Yeah, it's hard to work with the conversion. But the point is, when it gets below $1, I just don't care for the types of things that I'm doing.
Yeah.
And I think that's the way that most people probably are that are doing person-to-person transactions. It's just, if something is less than $1, it's just not worth it to think about it. Unless it's, well, I don't know in what case. Because if you were going to do something in aggregate where every time something costs, say, 37 cents, then you would just buy 100 of them or buy 10 of them, or, you wouldn't. You wouldn't say I'm going to get just one of these. It'd be like, oh, I'll just give you point one. You give me five of them, or whatever it is.
Yeah, got you. Would I be able to see like what like a sample wallet would look like as far as like coins, like denominated and non-denominated coins? Or is that spreadsheet that you had open earlier? Was that like basically what a sample wallet would look like, or is that just calculating like
I was just throwing stuff together,
okay,
but so here is no, that's not what I wanted.
what was it?
So here's a test wallet that I have,
Okay,
and the way that I've handled it is these S star values mean stamp. So basically, these are denominated, and then they have a stamp value. And so a stamp, essentially, it costs 192 satoshis, which is all the way down here in the millionths. It costs 192 satoshis in order to send a transaction. And so I just estimate a $200 or not 200 satoshis per input is always going to be more than enough to pay any transaction, or almost any transaction. There are some you could theoretically you could create so many outputs that you'd not be able to pay. But anyway, so I call this stamp value, and then that means how many times that you could transact this coin without it decreasing in value. Because one of the problems right now that's just a really weird user experience is you get this problem right here where I want to send you 0.2, but then because of transaction fees, what we end up with is 0.199983325, and this just doesn't feel good. I don't want to deal with extraneous fractions of penny. And so my solution is, well, once we get down past the thousandth, we just split it out into stamp values, and we don't count it as dash as money value. We count it as how many times could this be exchanged. And so these could each be exchanged between 83 and 99 times. But these ones are non-denominated. So if I'm looking at these, this could only be exchanged one time. This could only be exchanged one time. This could not even be exchanged one time. This would have to be broken to be exchanged. And then this was one that was broken. So what I'd like to see is just a value of 0.2, but what I see instead is 0.199, and that's just because it was transmitted without any what I call stamp values. It was transmitted without including any transaction fees. And if we could get rid of transaction fees, then this would become a heck of a lot simpler, but I think that's further down the road. I think if we could prototype this out with this stamp idea where when you look at your wallet, you never see any of the digits past these.
Mm-hmm.
You just see these digits, and everything else is just considered a stamp value of how many times could you transact this. So another weight that we might want to put on this is actually, and I wouldn't worry about it now at all, but just if we had everything else working, and this, icing on the cake would be if we have a coin that has a higher stamp value, send it because it can be sent more times for free, essentially.
Okay.
But this is kind of what things look like, and I could give you a printout of my wallet. I'll just send that to you in chat.
Yeah, I appreciate that.
But yeah, I'll send this to you in Discord. But this is what coin values actually look like in my wallet right now.
Okay. Okay, yeah, this problem definitely got more deep than I was expecting. I can see why you was thinking so hard on stream now earlier. There's a lot of different ways you got to think about this before you attack it. So Let me see. So yeah, the wallet that helps, so I can see what that looks like. Okay. Um.
And from the user experience perspective, like I said, part of the problem I'm trying to solve is I just want it. I want I want it to feel nice when you send and receive Dash. Because whenever I see a 0.199 or 0.499 or I just feel cheated, you know?
Yeah, yeah, yeah.
It's just like man, I was supposed to get a solid point two. I got cheated out of point 0.00000000001.
Yeah, yeah,
And I
yeah.
don't care about the value. I just care that I it's I just want an even number.
Yeah. Transaction fees, huh? I didn't even consider that at all. Um,
Yeah, so that's another thing that I was calculating here. So I've got a couple of different calculations for this. And let's see, let me go back in here. I've tried calculating a couple different ways, but the thing is, again, this is another part of the cyclic nature is you don't know what the transaction fees are dependent on the number of inputs and outputs. And so in order to know what the transaction fees are, you need to know the number of inputs and outputs. In order to know the number of inputs and outputs, you need to know what the transaction fees are. So you could actually do a calculation and then find out that it's wrong because as you increment the coins, you have to increment the fee. So the last coin you add has to be greater than the sum of the fees and the outputs, and every coin you add increases the fee. This also gets rid of that problem. This way of doing it, of denominating it, also gets rid of that problem because there's so much extra cruft, you will just tend towards having coins that have really high stamp values. And then whenever you include a coin in a transaction, the stamp value will get redistributed. So if I were to, let's say I were to include these 3 coins in a transaction, no matter what value the coin has, the number of stamps it has is going to be pretty high. And then we could just take the total number of stamps between all the coins and then write out the new average value to the coins that get sent. And so in that way, every time you're doing a transaction, you're kind of reloading any coins that are low in their transactability. And anytime you get a non-denominated payment, then you get a bunch of extra stamps that can go into future transactions. Because all of this extra stuff at the end is basically useless. But if you divide it among how many coins this makes, which this is going to be, I forget how many is 9. 9 is a 5 and 2 2s. So that's 3. So this is 6. So it's 7. So you'd take this, divide by 200, and then divide by 7, and then you'd apply it to each of the 7 coins equally, and then you'd end up with something like 300 transaction stamps on each coin. Anyway, I need to take a break.
yeah.
I'm gonna.
I'll think about this some more. I'm gonna think about this some more.
Thanks.
At least try to help you out. You've helped me out a lot over the past. I don't even know how long I've been just like chilling in your chat. But every time I tune in from now and then, I see what you're doing. It inspires me to continue on my journey, become being a better engineer and whatnot. So I want to say I appreciate you for that. Thank you. I do also go back from time to time and read some of your Beyond Code problem or videos that are just sitting on YouTube from years ago.
Cool.
I watch some of those. So thank you for everything. I just want to say that.
Yeah.
But yeah, I'll definitely think about this some more and then get back to you if I think I stumble across like some type of solution or something.
Like I said, we can get a Dash task for this, and you can submit the work for, fair pay for the the time that it takes to come up with it if you come up with a solution. So it doesn't just have to be a thank you. It can be a task that you get paid for.
Of course, cool. I mean, yeah. How does the Dash task stuff get set up? Like, what do I gotta do for that? Do I just go on?
You just join the Trello. Actually, in the Dash channel, if you click on, let me see if I can do this here. If you click on the channel, it should give you some links that are always there. I don't know where channel information went. There used to be channel information, and I thought you could just click on the title of the channel and it would show you, here's the subject of the channel or something like that. They may have taken that away. Let's see, edit channel. Okay, yeah, if you can see the channel topic.
Oh, I see. Is it get paid in Dash, sign up, Trello.com/whatever at the top?
Yeah. I can't see that. I don't know where that went.
It's at the top of my Discord for me. Like, it's next to the general Dash incubator channel name at the top. I don't know if you have a different Discord or what, but is it because you're in streamer mode? Maybe, I don't know. What?
Oh, streamer mode is enabled. Okay, is that it?
It might be. I don't know.
I had streamer mode enabled, but I don't know. This is what I see. I'll show you real quick. Let me bring it onto the screen here. So this is what I see.
Oh, it's because your Discord. You have to I think full screen your Discord, because I think it's in the window. If you enlarge.
Oh, okay, yeah. If I full screen it, it's up there. Yeah.
Yeah. Okay.
Okay, so you can. Yeah. So if you click on that, you'll see the links.
Cool.
So you basically you signed up. You just sign up, and then Ryan can work with you to propose a task and get pricing, but essentially you say, hey, this is what I feel is a fair value for this work, and then you can get the task up.
Got it. All right, I'll definitely go ahead and submit something on the board or sign up. I'll sign up first and then get the ball rolling. But yeah, and then once I do that, I'll start getting. Even before I do that, I'll start thinking about this some more and getting some work done. But for sure, thank you for allowing me to hop on this call with you. At least talk some of this out.
No, thank you, because it's really helpful for me just to rubber duck and just to have somebody else who's had some experience doing in the same vein of this, to not feel like I'm a complete idiot at this, because it is not intuitively obvious. It's not that I'm just being dumb. It's that this actually is a problem that's hard to solve. Because every once in a while, you get hung up on a problem, and then somebody comes along and they're like, well, do this, duh. And it's like, man, I can't believe I didn't think of that. In a way, I was kind of hoping that's what would happen, though. I was kind of hoping that, there's a really simple solution to this. I remember this. It's this. But yeah. Anyway, so I'm just going to go through with the to get this done today. I'm just going to go through with I think I'll do it this way. Pick the best coins that you can up until if it requires, there's got to be some sort of threshold that if it requires too many of a low value, that it'll pull from the next highest value instead. And it could be something like, if it needs more than 5 of the next lowest value, then pick the next highest value instead. That might be the right way to go about it.
Mm-hmm.
So it could be, at any level, try to get 5 coins in that, up to 5 coins in that level. But if that doesn't work out, then put the higher coin in instead, and then just rerun the calculation, and then the lower coins will drop out. That might be the way to approach it. Anyway, I'll figure something out that's more of a dumb approach, and we can circle back around to try a smart approach later.
Cool. All right. Until then, I'll let you go. I know you're busy. You got other things to do. But
Well, I just need to take a break and go get something to eat and drink at
got
this
you.
point. So that's all.
But yeah, I'll leave you to it then. Goodbye for now. Hope you have a good rest of your night and everything.
Thanks.
All right. Talk to you later.
Adios. Okay, so I'm going to go then. I feel kind of down a little bit that I didn't come up with the solution, but I also feel a little bit better in that it it that it's not intuitively obvious. But again, I just need to come up with the stupid solution first, the one that's not optimal, that doesn't work well, but that works in the that works in the ideal case. That's what I need. I need something that works in the ideal case and that's not terrible in the average case, and it's okay if it's dismal in the dismal case. So if we can just meet, if it's not bad in the ideal case and it's not terrible in the average case, it's okay if it's abysmal in the abysmal case. For now. All right. But with that, I'm going to get off. Likes, thumbs up, sub, follow, etc. Blah blah. If you want to. Oh, it's not there. I'll put that back up there. There. What? Nope, that's not. There we are. There it is. If you want to. I'll get back on and I'll finish this up for real. Oh, man. I will get this done today. It's going to get done today. That is going to happen. It's going to get done today. I need to be done with this. I need to move on. I need to let my brain sit on some other problems. This is one that it makes me anxious. I don't like things that I'm not good at. This is the kind of thing where I guess I would feel better about it if I was just doing this for fun. I would feel better about it. I don't like doing things for work that I'm particularly not good at. I think the problem is interesting, but I want to get something delivered. And that's where I feel a little frustrated and inadequate over this, because I've been spending almost 10 hours on this, and I don't have something delivered of this portion. The other stuff I also spent more time on, but I got to the point of delivering and feel good about it. This one, I'm staring at it and I'm just thinking, okay, no, I got to try this. No, I got to try this. No, and I'm wrong. I'm flat out wrong. I need to go for the stupidest solution, and then there needs to be somebody. Yeah, I'm convinced somebody else who's got that head on with the looking at the graph algorithms or whatever. It needs to be the other person that kind of takes a look at this and either walks through it with me or just comes up with the algorithm, and I could implement it, or we could talk about where the weaknesses are, or what the weights should be. But yeah, this is not as simple as it to not tend towards bad results. It's not as simple as pick the highest coin you can and walk down. And even in that case, like I said, there's still the problem of, oh, I don't have a 0.5. Let me use 50.01s. That's the thing I'm afraid of. That's the thing that I want to detect, because that's the thing that's because that's what I've seen so far with but I don't know, maybe I don't need to worry about that much. Anyway, I'm going to go. So thanks for joining in. I think it's just me and For God that are on here right now, so I'm not going to. What's the word I'm looking for? Raid. I'm not going to raid, but catch you later. Adios. Where's my sound?